Hi Lab, just wanted to follow up on our meeting today. I think I figured out how to tweak the formula so that we analyze the difference scores correctly for the Bayes task. So in the interest of moving things along, I'll pass that information on to you now so that you can apply this to your data analysis. And then we can get an understanding of what's going on with the task more quickly. So the first thing you'll do, so you should have, MATLAB spits out something like this, possibly including this. This K column here. I think this is the last thing that MATLAB spits out. So the first thing you want to do is convert your data to degrees. So just you can multiply in column L here, you can multiply your first score. I think this is the physical orientation of the stimulus. You can convert that to degrees by multiplying it by 57.2958. And then same thing for the second score, which I think is the angle that you put the line at. Convert that to degrees, and then you can just take the difference between those, like the second one minus the first one. And then what you're going to do is say how many times does 180 go into that. And if it goes in one, and you're going to round that up to the nearest whole number. So this 203 goes in, one time. Let's see, this is, 180 doesn't go into 108, but it goes in more, it's 108 is more than half of 180, so we still get a 1 value here. So I think this number looks like it's behaving properly. And then what we do is, so you just copy this formula, put it in your thing next to your different score formula, and then you're going to have this guy P. This is a note I wrote earlier when it was incorrect, but now it's correct, so I'm just deleting that. In the P column, you have, let's see, yeah, you have your N2 minus this number times 180. So if, like for example, here, look at this lovely trial. Somebody, Abigail, I guess, because we're on her tab. The 205 was the degrees of the physical stimulus. She put it at 217, so there's no issue there. The difference is 11. We don't have to do any kind of correcting, nor do we do any kind of correcting. So it stays at 11 because it's multiplied by 0 times 180. This one is a different story, so it's 180 was the physical stimulus, so a flat line essentially, and Abigail said 72, which is really a terrible response. I mean, it's almost, 72 is almost 90 degrees, so it's almost as bad as it could be. So that gave us a difference of 108, but really, remember we were saying the maximum difference you could truly have is 90, because if it's 108, it's like just closer to the other orientation of the flat line. So here we would want to make a correction, and in fact we do. We multiply, what do? We take this minus 180, and that gives us 71, which is correct. So I believe all these numbers are right. I scanned through them, and we can talk about this more next time if you're still confused, but for now, I think this is right. We don't have any numbers that are bigger than 90, which is good, and we do have positive and negative numbers, and we have an average of those numbers, which is very close to 0. It's 3 out of the maximum value, but I guess it could be 360, or really maximum would be 90 practically, but it's 3, which is pretty close to 0, so that makes me happy. And what we can do is once you guys have all I want you to do is just do what Abigail did for now. Let's do that and just take all your data, at least for your like regular data. I think I told you guys to do like 5 trials or something, or five rounds of data collection. So for all your like baseline data, I know I had some of you guys like tweak the task. Let's not worry about that for now. Let's just look at your regular data for the baseline condition. And for both the sequential and the simultaneous. So do it twice, once for each. Just slap them all on top of each other, and then create this guy. This is like the money shot. This is our real data. So then we can just grab those data, copy them, put them in a MATLAB, which I already did here for Abigail. Just paste them in. Abigail data equals that, and then if we can use the MATLAB function histogram Abigail data, and that's already over here. It makes this nice histogram. So most of her answers were close to 0 error, or they were within, looks like it's a little off center, but that's okay. Within, within, I'd say 15 degrees on average of 0. So that was the most common response. She had 45 answers or so that were within 15 degrees of 0, which is great. But then she also had a lot that were between like 15 and 45 degrees. So she had 29 and 33 of those in either direction. And then she had a few that were like really bad, like approaching 90, as bad as it can be. So this is very nice. You know why? Because this is exactly what Bayes did in this whatever year it was, 2011, 2013 maybe, paper. And you can see this is exactly, well, Bayes has more, 1, 2, 3, 4, 5, 6. Bayes has 13 bins, and we only had 7 bins in that little histogram from Abigail, but that's just because we had fewer trials. But what I'd like to do is get like this nice little bell curve for each of you, and we can see how it compares with Bayes' bell curve. Okay, very good. Well, good luck with that. Let me know if you have questions, but I hope from that you'll be able to, you don't have to worry about doing the histogram. You just have to, if all of you can do this, that would be great. I guess Abigail's done, but Abigail, you can do it for your simultaneous data as well. Maybe you could each have two tabs if you want, or just put it somewhere else in this tab that's clearly labeled that's simultaneous versus sequential.